Okay, so question over here says 2 point charges minus 10 nanocoulomb and minus 90 nanocoulomb are placed 80 meter apart. So let me just write here minus 10 nanocoulomb and over here it's minus 90 nanocoulomb and both are placed over here at 80 meter apart. Okay, fine. The point on the line joining the two charges where the field intensity is 0. So let's assume that the field is 0 at point P. Okay, now and that's at a distance of x. So here it will be how much? 80 minus x from charge B. So from charge B it is 80 minus x, from charge A it is x. So let's draw the directions. Both are negative charges. So electric field at point P due to charge at A will be radially inward towards the charge. So this is EA. And electric field due to the charge B, that is again negative. So it will be EB in this direction. And since the angle is 180 degrees, so we can say that EA minus EB at point P will be 0. That will be resultant. So EA here will be equals to EB. And that implies EA is nothing but K charge on A upon separation AP square. That must be equals to K charge on B over BP square. K and K gets cancelled over here. QA charge on A, that's 10 nanocoulomb, 10 into 10 to the power minus 9 upon AP is x square. That must be equals to 90 into 10 to the power minus 9 whole divided by 80 minus x whole square. Let's cancel out this with this and cross multiplying we will get here 80 minus x whole square whole divided by x square will be equal to 90 over 10. Let's cancel out 0 with 0. And taking the root, it will be 80 minus x whole divided by x must be equal to 3. So 80 minus x must be equal to 3x and that will give us 80 equal to 4x. Hence x is 20 meter. That's our correct answer. Option B. Let's move to the next one. Okay, let's see here. The question says 2 point charges are placed as shown in the figure. The net electric field due to both the charges at point P. Now first of all 20 nanocoulomb, as we can see the 20 nanocoulomb is positive charge, so it will be radially outward, so it will be like this. This will be, let's call it as A, let's call it as charge B. So electric field due to A will be EA and the electric field due to B, that also will be radially outward, so that will also point in this direction. Let's call it as EB. Now since they both are pointing in the same direction, net electric field E must be equals to EA plus EB. And EA is nothing but K charge on A upon separation AP square plus K charge on B whole divided by BP square because the separation is BP. Now K is common in both of them. So let's write here 9 into 10 to the power 9, that's K value. And QA is 20 nanocoulomb, so 20 into 10 to the power minus 9 whole divided by AP, that's 2 square, plus the second charge is 32 into 10 to the power minus 9 whole divided by BP, that's 4 square. Any doubt? Now here we can take 10 to the power minus 9 out and that will cancel out. So this E total will be equals to, we can write here 9 and 10 to the power 9 and 10 to the power minus 9 will go and we left with here 20 over 4 plus 32 over 16. 20 over 4 is nothing but 5 and 16 twos are. So 5 to 7, 7 nines are 63. So E total will be equals to 63 Newton per Coulomb. That's our correct answer. Option C. Any doubt? So question over here says 2 point charges plus Q and 4Q are separated by a distance of 6A. So let me just draw this. Let's say this is our Q and let's say this is our 4Q and both are separated by a distance of 6A. So let me just draw here as 6A. The point on the line joining the two charges where the field is 0. So let me just take it as A and let's take it as B, and the point at which the field is 0, let's call it as point P, and let's assume that this is at a distance x. So this will be 6A minus x. So point P, the electric field is 0, electric field due to the first charge, both are positive, so it will be radially outward EA, and due to B, it will be radially outward in this direction EB. So net field at point P will be equals to EA minus EB because they are both in opposite direction. 0, that will give you EA minus EB, or we can write it as EB equals to EA. Now what's our EB? Electric field due to B, that will be K. The charge is 4Q upon separation is 6A minus X whole square. That must be equal to K, the charge on A, which is Q, upon how much? X square. So K cancels with K, Q cancels with Q, and let's cross multiply. So 4 will be equals to 6A minus X whole square whole divided by X square. That will be 2, that will be equal to 6A minus X whole divided by X, and that would give us 2X is equals to 6A minus X. 3X will be equal to 6A, and X will be equal to 2A. That's our answer. So correct answer is option B. So question over here says 2-point charges are placed as shown in the figure. The net electric field due to both the charges at point P. So first of all, due to minus 36 nanocoulomb, it will be radially inward towards the charge. So let's call it as A, let's call it as B. So it will be electric field EA. That will be towards the charge because it's negative. For the second charge as well, it will be towards the charge, and this will be EB. Correct? So the net field at point P, that will be the sum of EA plus EB. Right? And EA is nothing but K QA whole divided by AP square plus K QB whole divided by BP square. Let's take common out here. K is 9 into 10 to the power 9. QA is nothing but 36. Do we have to take negative sign? No, because we have already assumed it in the directions, right? So AP is nothing but 6. So 6 square plus QB, that's 12 into 10 to the power minus 9 whole divided by the separation between B and P, 2. So that's square will be 4. Let's take now, let me solve it here. So net electric field at point P will be equals to, let's take 10 to the power minus 9 common out and cancel with 10 to the power plus 9. So it will be 9 into 36 over 36 plus 12 over 4. So that will give us 9 into 36 over 36, 1 plus 3. So that will be 36 Newton per Coulomb. That's option A. Understood? Okay, so the question says 2-point charges are placed as shown in the figure. The net electric field due to both the charges at the midpoint. So midpoint, let's assume that this is our midpoint over here. And at this midpoint, let's call it as P, let's call it as A, let's call it as B. And the field due to the negative charge, minus 36 nanocoulomb, will be radially inward. And let's call it as EA. Electric field due to B will be towards the charge B, that will be EB. And since the angle between them is 180 degree, the net field at P will be equals to EA minus EB. And EA is nothing but K charge on A whole divided by separation, which is AP square, minus K charge on B whole divided by BP square. Now what's common in both? Common in both is K, and AP and BP are equal because it's a midpoint. So let's call it as K upon AP square is common out. We left with charge on A minus charge on B. So let's substitute the values. K is 9 into 10 to the power 9. AP square is nothing but 2 square, which is 4, into charge on A, 36 nanocoulomb. So let's call it as 10 to the power minus 9 minus 12 nanocoulomb, which is 10 to the power minus 9. Let's take 10 to the power minus 9 common out, and that will cancel out, and we left with 9 by 4 into 36 minus 12. 36 minus 12 is 24. So that will be 6 9s are 54 Newton per Coulomb. That's option B. So let's see the question. Question over here says 2-point charges of 6 microcoulomb. So let me just draw here. This is 6 microcoulomb and 24 microcoulomb. So let's say this is 24 microcoulomb are separated by a distance of 6 meters. So let's say this is our 6 meters. The point on the line joining them where the field is 0. Let's take this as P. Let's say this is A. Let's say this is B. And let's say P is where the field is 0. So this is X. This will be 6 minus X. So the net field at P is 0, which means EP. Now electric field due to the first positive charge radially outward, so this will be EA, and electric field due to B, that will be radially outward, EB. So net field at P will be EA minus EB. Now EA is nothing but K charge of A upon the separation AP square minus K QB upon BP square. Now since it is 0, let's put it 0 and take it on the other side. So K will get cancelled and we left with QB upon BP square will be equals to QA upon AP square. Now QB is nothing but, let me solve it here, QB is nothing but 24 microcoulomb, so 24 into 10 to the power minus 6 whole divided by BP. BP is nothing but 6 minus x whole square, which is equals to charge 6 into 10 to the power minus 6 whole divided by x square. Let's cancel out this with this and cross multiply. So 24 by 6, that will be 6 minus x whole square upon x square. 24 upon 6 is 4, and taking the root, it will be root of 4, which will be equal to 6 minus x upon x, and root of 4 is 2. So 2x equals to 6 minus x. 3x is equals to 6, which implies x is equals to 2 meter. That's option C. The question says over here, 2 point charges 2 microcoulomb, so 2 into 10 to the power minus 6 and 50 microcoulomb, 50 into 10 to the power minus 6 are separated by a distance of 24 meters. So this separation is 24 meter. The point on the line joining them at which the field is 0. So let's assume this is point P, this is our A, this is our B, and electric field at point P is 0, which means EA must be equals to EB. And since they are positive both, so the field direction will be radially outward. So it is EA, this is EB, and let's put here values. K cancels with K both the sides, so charge Q upon R square, which is x square. Let's assume this is x, and that will be 24 minus x of 50 into 10 to the power minus 6 whole divided by 24 minus x whole square. Let's cross multiply. So 24 minus x whole square upon x square will be equals to 25. So taking the root both the sides, it will be 24 minus x over x will be equal to 5, and that will give us 24 minus x will be equal to 5x, and 24 equal to 6x, which means x is 4 meters. That's our correct answer. Option B. Okay. So in the last lecture we did electric dipole. Now today we will find electric field due to an electric dipole at different points. Okay. Dipole, we have already discussed in the previous lecture. I am just repeating again. It is a pair of equal and opposite charge q and minus q separated by a distance 2a, right? And here what is important parameter for this is electric dipole moment, and electric dipole moment is given by P, which is equal to 2aq, and the direction is always from negative to positive. Be very careful with this particular thing, right? So let's find now our first derivation in this chapter. Okay, very important derivation, that is our electric field due to an electric dipole on the axial plane, So let's see what is electric field due to an electric dipole on its axial plane. Very important, but very important derivation. Okay. So let's see. This is our minus q charge and this is our plus q charge, and they both are separated by a distance 2a, because this is our electric dipole, right? Now we are finding the field at axial plane. What is axial plane or what is axial point? Axial plane or axial point is a point along the axis of the dipole. And what is the axis of the dipole? This direction. So we will draw a point over here, and let's say this is our point P at which we are finding the electric field due to this dipole. What is important here is this point P, the distance we will take will be from the center of the dipole. So this gap is our R. So this is our center. So from here, if this is R, this gap is let's call it as A, let's call it as B, let's call it as O. OB is nothing but A, and AO is nothing but A, right? So as we have done in the previous problems, numericals also, let's first find the direction. So electric field at point P due to charge placed at A will be towards the charge, so it will be EA. Electric field at point P due to the charge at B, which is radially outward, so it will be EB. The angle between EA and EB is 180 degree, and if two vectors are aligned at 180 degree, the resultant electric field at P will be EA minus EB. EP is the axial point, right? And that will be EA minus EB. Or you can also do EB minus EA. Okay. So better is to choose EB minus EA instead of EA minus EB. Sir, why? Because you can see that the charge B is closer to point P, so the intensity of electric field will be more compared to the charge at A. So EB minus EA will be a better choice. Otherwise, you will get a negative sign, so it doesn't make any difference. That magnitude we can remove that. So EB, let's find EB. So EB will be charge K. The formula for electric field is K. Charge on B, that's Q, whole divided by the separation, that is BP square, minus K Q. Again I am repeating, we will not take the negative sign. Okay, whole divided by AP square. Any doubt? So let's take KQ common. So KQ taking common, here we left with 1 by BP square minus 1 by AP square. Now, what is, sir, BP? So this K, I am just writing it as 1 by 4 pi epsilon naught. Charge is Q. BP. Now, if you be very careful, BP is nothing but 1 upon R minus A whole square. That's our BP square. And what is our AP? AP is 1 over R plus A whole square. This is our electric field. Let's simplify it further. So here on simplification, this will give us Q over 4 pi epsilon naught, multiplying, cross multiplying, it will be R plus A whole square minus R minus A whole square, whole divided by, cross multiply them, it will be R minus A whole square into R plus A whole square. I hope this is clear. Now, let's simplify it further. It will be Q over 4 pi epsilon naught. Let's expand the numerator, A square plus B square plus 2AB minus A square minus B square plus 2AB. Be very careful. I have directly opened it because the signs will flip. Now, in the denominator, if you be very careful, we can rewrite this expression as R minus A, R plus A whole square. Sir, how can you write that? X square into Y square will be written as X into Y whole square. Yes, so that's the same thing. So here, let's simplify it further. So it will be Q over 4 pi epsilon naught, and let's cancel out R square with R square, A square with A square. We left with 4AR upon R square minus A square whole square. And 4AR, that can be splitted as Q upon 4 pi epsilon naught. We can split 4AR as 2 into 2AR upon R square minus A square. Any doubt? 4A is nothing but, why we are splitting it? That's a good question. So it will be 2AQ into R whole divided by 4 pi epsilon naught into R square minus A square whole square. And what's our 2AQ? That's our dipole moment. So net electric field at any point on the axial point at a distance of R will be 2P, be very careful, R upon 4 pi epsilon naught R square minus A square. That's our outcome of electric field on the axial plane. Now, if there is a condition, if R is very, very far away, R is much, much greater than A, then R square will be much, much greater than A square. then r square minus a square will be approximately r square only, right? And in that case, our net electric field will be rewritten as 2pr upon 4 pi epsilon naught r square whole power 4. We can cancel the numerator 1 of the r, and we got, for an assumption that if r is much greater than a, then it will be the, this r will be removed and this will be r cube. So electric field is inversely proportional to r cube for a dipole. And from where we got? Yeah. Exactly. R square whole raised to 2. Okay. So that will be our So what we conclude up till here is electric field due to, I'll go to other side. So electric field, what we conclude that electric field E due to a single charge is 1 by 4 pi epsilon naught q by r square. But what we got for an electric field due to a dipole on a axial plane. So let me just write here dipole, and along with this dipole on the axial, because one more point we will find in the next lecture. So that we found as 1 by 4 pi epsilon naught, and how much we got? 2p by r cube. So for a single charge, it is inversely proportional to r square. But moment the charge increased, it became a dipole, it became inversely proportional to r cube. Understood? Yes.